we're going to go through question 8 very briefly. So for part 1, I've gone through something similar in the previous questions. So simply put, you need to isolate x. How do you isolate x? Use your quadratic formula. So your quadratic formula will give you this. And from here you simplify. Okay. The key point is that here they ask you to give them in similar form. Means you have to give them back in this form here exactly. F is such that x is mapped to 6 minus x squared, where x has to be less than or equals to negative half, and x is in the set of real numbers. Each and every symbol in this whole line notation actually has a meaning. Don't neglect the meaning. So actually the answer, which you can see in the numerical answers also, is F inverse is such that x is mapped to negative 25 over 4 minus x minus half, where x is in the set of real numbers and x is less than or equals to 25 over 4. Now the key point here is why did I choose the negative one? Well, you see that in the original working it was plus or minus. Remember that in my original function f, I needed x to be less than or equals to negative half. If you look at this original working here, I actually then have negative half plus minus something. Obviously, since I'm doing an inverse function, I want to get back to something that's less than negative half, so you choose the minus option rather than the plus option. Seems quite dull, right? Yeah. The next one. Find the range of G. The simplest method for this kind of thing is really always just to sketch it out. Graphs are always the easiest method to see anything. So when you sketch it out, you see that there's a horizontal asymptote of y equals to minus 2. Okay, and a graph. Okay, that wasn't a very good drawing. That looks something like this. It seems fairly clear from this graph that the range of G is negative 2 not inclusive because there's an asymptote all the way up to infinity. That's all. Okay. State why the composite function hg does not exist. We just went through this in the previous question, and the key point here is for it not to exist. Remember, the range of G cannot be a subset of the domain of H for it not to exist. If it does exist, then the range of G needs to be a subset of the domain of H. Okay, so you just need to work it out. Find out where is the range of G, where is the domain of H, and show that, well, the range of G is not a subset of the domain of H. Part 4. By restricting the domain of G to something to infinity. Oh dear. Alpha infinity, where alpha is in the set of real numbers. Find the smallest value of alpha in exact form such that the composite function hg exists. So for this bit, you actually need to know the domain of G, the range of G, the domain of H, and the range of H. The original domain of G was the set of real numbers. The original range of G is -2 to infinity. Original domain of H, let me see what is H, is x bigger than 1, so it is just 1 to infinity, and we'll leave the range later. But remember, I just need to know now that my composite function hg must exist. So how do I restrict my range of G such that it becomes a subset of the domain of H? Clearly, my range of G, the maximum range of G I can have, needs to be 1 to infinity. Okay, this is another one. So I look back at my graph again. This is why I like the graph a lot. When y goes to 1, what value does my x have? Okay, so we solve for that. 1 equals to so I have x equals to ln 3, and clearly, so long as from x equals to ln 3 onwards, as long as I throw away everything from ln 3 downwards and only take my domain to be ln 3 upwards, my range is going to be 1 to infinity. So my new domain of G is going to be ln 3 into infinity. Okay. So what the question wanted? No, they say exact form, so I just leave it in ln 3. So now I have to define Hg. This is not important. Okay, Hgx equals to h of you can leave it like this form because they did not say define Hg in a singular form. If they had said define Hg in a singular form, then we would have needed to write Hg such that x is not to ln of ln e to the power of x minus 2. Where x needs to be a set of real numbers and x needs to be between ln 3, oh no, sorry, x just needs to be greater than ln 3. Okay. Lastly, you asked to solve the equation hgx equals to ln 2. So hg, you already know, has this relationship. So I have ln of something equals to ln 2, and from here you should get ln e to the power x minus 2 equals to 2. To undo the ln, e to the power of 2 equals to e to the power x minus 2. And for those who cannot remember, this is from y equals to ln x. Okay, I'm not going to start from this. Log a b equals to x means a to the power of x equals to b. Think about this. So one of the core definitions of logarithms that you really need to remember. Okay, so we will go on from here. I have e to the power of x equals to e squared plus 2. And now because I actually want to solve for x, to isolate the x, I need to log it. Remember that ln e equals to 1 because it's the same base, and I have solved for x. X equals to this.